Today we're going to talk about the mean value theorem 4.2.
So the mean value theorem is represented by this equation, and if y of f of x is continuous at every point of the closed interval and is differentiable at every point of its interior, there will be at least one point in the interval. In other words, the function has to be differentiable, continuous, and closed.
The mean value theorem shows the direct correlation between instantaneous and average velocity. In other words, the direct correlation between the tangent and the secant line of a function.
Theorem, you have to just check if it is continuous, differentiable, and closed. You can remember this by CDC. You have the function f of x equals x squared, and it is on a closed interval. It is differentiable, and it is continuous. So you can apply the mean value theorem.
Go.
In this function, the secant line has a slope of 2, and the mean value theorem shows that somewhere else on this function there will be a slope of 2. If the equation confuses you, you can change it to f of c equals c squared. Then we take the derivative, f prime of c equals 2c, and then we find f of b, which is 2, so we have 4, and then f of a, which is 0, all over 2 minus 0. And c equals 1. So, at 1, the slope of the tangent is equal to the slope of the secant.
You're driving a car and a of x equals x squared. Find where your average and instantaneous velocities are equal between the points 0 and 10. Apply the mean value theorem.
F prime of c is 2x, and f of b is 100, f of a is 0, and then 10 minus 0. 2x equals 100 over 10, 2x equals 10, and then x equals 5. So at point 5, your secant and your tangent line are equal.
We apply the mean value theorem for increasing and decreasing functions. If the derivative of the function is less than 0, the function is decreasing. And if the derivative of the function is greater than 0, the function is increasing. For the function 5x minus x squared, on the interval negative infinity to infinity, we are going to find where it increases and decreases. First, you take the derivative. And then you set the derivative equal to 0. So 5/2 is where it changes direction. So then you take a point to the left and to the right. So and you just plug it into the derivative. Since the derivative at 2 is 1 and the derivative at 3 is negative 1, the function is increasing on the interval negative infinity to 5 over 2 and decreasing on the interval 5 over 2 to infinity.
Next, we will talk about antiderivatives. You find an antiderivative using the process of antidifferentiation. Given the derivative y prime equals x to the 5th, find the antiderivative, or basically the original function. To find the derivative, you multiply and then you subtract, and to find the antiderivative, you add and then divide. So adding would be x to the 6th, and then divide it by 6. And you always add this.
Next we're going to find the antiderivative of this function and solve for c using the point 0,2. So you know that the antiderivative of sine is negative cosine of x. And then you have to remember to put your plus c. So now you take this point and you plug it in. So 2 equals negative cosine of x, or negative cosine of 0 plus c. So then the negative cosine of 0 is negative 1 plus c, and 3 equals c. So your final function is negative cosine of x plus 3.